So now let us begin with the cube root of perfect cube. So for finding out the cube root of perfect cubes of bigger numbers, one must be familiar with the cubes of single digit. 1, 2, the cube of 1 is 1, cube of 2 is 2 into 2 into 2, 3 into 3 into 3, likewise. Six cube, 216, 343, 512, 729, and 10 cube is 10 into 10 into 10, which is 1000. What is the speciality in the numbers and their cube that we'll see? Just observe the unit place of cubes. So here it is 1, here it is 8, 27, 7 is unit place, here it is 4, here it is 5, here it is 6, 3, 2, 9, and here it is 0. And the next thing is Bijang. So Bijang of 1 is 1, Bijang of 8 is 8, Bijang of 27 is 2 plus 7, 9, and 9 we are cancelling for finding out Bijang, so you may consider it as 9, or you can, because we are cancelling, we can write it as 0 also. So again 64 is 1, 125 is 8, 216 is 9 or 0, again 1, 8, 0, 1000 means 1. So if you observe and so on, when the cube, a perfect cube, it has the Bijang either 1 or 8 or 0. So when a number, just you observe and see its Bijang, if it is other than 1, 8 or 0, definitely it is not a perfect cube. But if it is 1, 8 or 0, it may be a perfect cube, it may not be a perfect cube. For example, if we take 27, which is 3 cube, its Bijang is 0 and it is a perfect cube. But 72 is not a perfect cube. Though its Bijang is 0. So when the Bijang is 1, 8 or 0, it may be or may not be a perfect cube, whereas if it is other than 1, 8 and 0, definitely it is not a perfect cube. Now if you consider the cubes of single digits, 1, 2, 3, 4, 5, 6, 7, 8, 9, the cube is minimum of 1 digit or 2 digit or 3 digit. So single digit its cube is 1 to 3 digits. When it exceeds 3 digit, cube of 10 is 1000, which is 4 digits. So for 2-digit number, its cube is either 4-digit or 5-digit or 6 digits. So when the number contains 4 to 6 digits, its cube root is 2 digit, and it continues for 3-digit number, it is 7 to 9, 7, 8 and 9 digits. Then its cube root is of 3 digit. So 4-digit number, it will have a cube of 10 to 12-digit number. So when we want to find out the cube root of this, just by observing the total number of digits, we will come to know what is the cube root, or how many digits are present in the cube root. So now let us see how to find the cube root of 39,304. So before proceeding to this, finding out the cube root, let us see the relation between a number and unit place of the cube. So here it was 187456329, which we have written it here. And just observe, 1 ends with 1, 4 ends with 4, 5 ends with 5, 6 ends with 6, 9 ends with 9. So 1, 4, 5, 6 and 9, they end or their unit place is same, 1, 4, 5, 6 and 9. If you observe number 2, 2 ends with 8, and if you observe 8, it ends with 2. So 2 ends with 8, 8 ends with 2. Similarly, 3 ends with 7 and 7 ends with 3. Just reverse. So 2 and 3 only interchanging takes place. It is a complementary from 10. 2 plus 8 is 10. 3 plus 7 is 10. So 2 ends with 8 or 8 ends with 2. 8 plus 2 is 10 or 2 plus 8 is 10. 3 ends with 7 and 7 ends with 3. 3 plus 7 is 10 or 7 plus 3 is 10. So complementary from 10 of 2 and 3 interchange. Rest all other digits remain as it is. 1 ends with 1, 4 with 4, 5 with 5, 6 with 6, 9 with 9. And minimum number of digits is 1, maximum single digit having 3 digits. So for finding out the cube root of such numbers, we group 3 digits from right. Now you observe only unit place number. It is 4. So as we can see, 4 ends with 4. So its unit place value of cube root is 4. Now observe second group, 39. Which maximum number you can subtract from this second group or left hand part of the group. So 39 you can subtract 27 maximum. You cannot subtract 64. So 27 means its cube root is 3. So cube root of 39,304 is 34. So it will take hardly 5 to 10 seconds to observe what is the cube root of a number. Now we will take some examples and directly solve what is the cube root of those perfect cube numbers. So these are the numbers, our perfect cubes are there. What is the cube root of these numbers? The first and foremost fact is you group 3 digits. So here it is like this. Now as far as unit place is concerned, 3 ends with 7 and 103, which you can subtract. You cannot subtract 125, but you can subtract 64. So its cube root is 4. So 47 is the cube root of 103, 823. 250047. So 7 ends with 3. 250 we can subtract 216 whose cube root is 6. 357 357 you can subtract 343. So it is 7 and 1 ends with 1. Like this directly now you can write the cube root of such numbers. 884. So 729 you can subtract and 6 ends with 6. 140, 125 you can subtract, 8 ends with 2. 614 you can subtract 8 and 5 ends with 5. 21 you can subtract 2 and 2 ends with 8. 970, 9 ends with 9. So 970, 299, it has 99 cube. So like this, within 10 seconds each, you can write the cube root of perfect cubes. So just you have seen how to find the cube roots between 2-digit numbers 10 and 99, and they were 2-digit numbers and their cubes were 4 to 6 digit. If the number of digits in the cube will be 7 to 9 digits, their cube root will be 3 digits, as it will form 3-digit number, a 3-digit number one group, 3-digit number another group, and remaining either 1 or 2 or 3-digit number. So that 3 plus 3, 6 plus 1 or plus 2 or plus 3. So 7 to 9-digit number will have a cube root of 3 digits. So how to find cube root of such big numbers, we'll see. So first we'll deal with a perfect cube which end with odd digit or odd ending numbers. So find the cube root of 800 62991. So if you observe, if you bifurcate or grouping of 3 digits from right, 991 will be one group, 062 is another group, and 80 will be the third group. So its cube root will be having 3 digits. So before proceeding to finding out cube root of such big numbers, we will be correlating arithmetic with algebra, where it is a plus b plus c whole cube that is involved. So if the number is say 435, then value of 4 is 400 because it is at hundreds place. So this is A, this is B, this is C. So you will get the answer as A as 4, B as 3, C as 5. So if we write the expanded form of A plus B plus C cube, it starts with maximum power of A, which is A cube, followed by, after A cube there will be A square, and finally it will be C cube. Earlier to that, it will end with C cube, maximum power. Earlier one is 3bc square. We are not interested in any of the middle terms. Suppose if we subtract from this terms C cube, C cube minus C cube is 0. So what is left is 3bc square and earlier terms. That means when C cube is subtracted from A plus B plus C whole cube expansion, it ends with 3bc square. And now we will start with finding out the values of A, B and C and how to correlate algebra and arithmetic. So first group, number 1, because the number has ended with 1. So the value of C is 1. Last group is 80. So how much we can subtract maximum? 4 cube 64 we can subtract, but not 5 cube 125. That's why the value of A is 4. Now only we will have to find the value of B. So how to find the value? Subtract C cube. One ends with 1, so that C cube, value of C cube is also 1. So subtract 1. So 1 minus 1 is 0. Cancel this 0 as we have cancelled C cube. What is left is 9 and so on. We are not at all interested in any of the digits earlier. So if we compare this arithmetic with this algebraic expression, we have subtracted C cube and we have subtracted the value of C cube. So this has ended with 3bc square. This is ended with 9. So the straight relation is 3bc square ending with 9. Now here we know the value of C, 1. C square is, again 1 square is 1 into 3. So in terms of B, we get 3B ending with 9. So for example, if 4B is equal to 12, so how we find the value of B? 12 divided by 4. In the multiplication table of 4, 4 3s are 12. Therefore value of B is 3. In the similar fashion, what we will be doing is B ending with 9 divided by 3. So in the multiplication table of 3, where it ends with 9, 3 3s are 9. So value of B is 3, which we have found out now. So the cube root of 8006291 is 431. It requires hardly 2-3 steps and you will get the answer. So find the cube root of 203,46417. Again grouping 3 digits. So 7. So we will have to find the value of A, B and C. 7 ends with 3. So value of C. 20, we can subtract 2 cube as 8. 3 cube 27 we cannot. So value of A is 2. We will have to find what is the value of B. So 3 cube 27. So 7, 11 minus 2 is 9. So 3bc square ends with 9. So c square, 3 square is 9. 9 3 the 27b ending with 9. Here also, as we have taken only unit place, we need only unit place. So 7b ending with 9. So b is equal to something. So in the multiplication table of 7, where it ends with 9. So 7 7 is 49, ends with 9. So value of b is 7. So our cube root is 273. What is the cube root of 234, 885, 113? Grouping A, B, C values we have to find. Three ends with 7, so value of C is 7. 234, we can subtract 216, which is 6 cube, and now we have to find the value of B. So subtract C cube, which is 343. So as we are interested only in single digit in B, wherever now 7 cube we have subtracted, 7 square is 49. Because we want only single digit, you consider only unit place of 49, which is 9. 9 into 3 is 27. Here also unit place of 27 is 7. 7b, which ends with 7. Therefore b is equal to something 7 divided by. So 7 ones are 7. So b is equal to 1. So A, B, C, 6, 1, 7. So the cube root of this number is 607. So find the cube root of 148, 035, 889. Grouping 3 digits, we get 9 ending with 9. That is the value of C. 148, you can subtract 125, which is 5 cube. So 5. Now subtract C cube, means 9 cube, 729. 8 minus 2 is 6. 3bc square. So 9 square, 9 9s are 81. Unit place is 1. 1 into 3 is 3. So 3b ending with 6. So therefore b is equal to multiplication table of 3, where it ends with 6. 3 2s are 6. So value of b is 2. The cube root of this number is 529. So when the number ends with odd digit, odd ending numbers, easily you can find out the cube root of such numbers. Now let us deal with some numbers which are even ending, and what is the difference between odd ending and even ending. So grouping of 3 digits. So we will have to find the values of A, B and C. Now 4 ends with 4. So value of C is 4. Third group is 2. In 2, how much we can subtract? 1 cube or 1 we can subtract. So value of A is 1. Now subtract C cube. 4 cube is 64. 10 minus 6 is 4. 3bc square. So value of C is 4. 4 square is 16, means 6 at unit place. 6 3 the 18, means 8 at unit place. So 8b ends with 4. Therefore b is equal to dash 4 divided by dash 8. So in the multiplication table of 8, where it ends with 4, we just say the multiplication table. 8 3s are 24, which ends with 4. 8 3s are 24, ends with 4, and 8 8s are 64, which also ends with 4. So we are getting two values for b. In case of odd numbers, we were getting only one value of b, whereas in case of even ending numbers, always we get two values of b. So either the answer is, if b is equal to 3, the answer is 134, which is the cube root of this, or if b is 8, it is 184. One of the answer is wrong, one of the answer is correct. So how to identify which answer is correct, which answer is wrong? So easy method is Vedic check. So 134 cube must be this, or 184 cube must be this. So what is the Bijang of this? 4 plus 3 plus 1, 8. 8 cube is 512. Bijang is 8. And 8 1 cancels, 4. 4 cube is 64, means 1 is Bijang. Compare what is the Bijang of this number. It is 8. So 8 Bijang tallies with 8 Bijang. So 134 is the correct answer, 184 is the wrong answer. So now we have seen that the cube root of 2406104 is 134. Now because the number is an even number, you can just say that minimum even factor 2 is present in this. When minimum factor 2 is present in this number, say 134, that means when it is cube, 2 cube is 2 into 2 into 2 is 8. 8 is a minimum factor that is present in this cube. So what you can do is just divide the number by 8 so that it is one of the factors. So it is, when we divide 2406104 divided by 8 will give 300763. That means 2406104 is nothing but 8 into 300763. So the cube root of this number means cube root of 8 into 300763. So cube root of 8 is how much? 2. and this is a 6-digit number. So we can easily find out what is the cube root of this number. So 300 we can subtract 6 cube 216, but 7 cube 343 we cannot. So 6 and 3 ends with 7. So cube root of this number is nothing but cube root of 8 into this, which is equal to 2 into 67, and the same answer we got it earlier. So either this way. So whenever even number is there, go on dividing by 8. So if next number is also even and more than 6 digit, if it is 6 digit, whether it is odd or even, you can find the cube root. If it is more and even, one more time you do like that. So each 8 will constitute for 2 as a cube. So first, why we get 2 values for B when we apply the formula A, B and C values. So it is in any multiplication table of even number. So let us consider odd number. Any even number you can take, say 2, 4, and you consider one odd table. In case unit place, if you observe, all digits are distinguished. All are different. Here it is 1, here it is 2, 3, 4, 5, 6, 7, 8, 9, 0. All are different. Whereas if you consider even multiplication table, 2 is repeated, 4 is repeated, 6 is repeated, 8 is repeated, and of course 10 is repeated. So for even multiplication table, we always get 2 values. So either 1 or 6, 2 and 7, like that. Whereas in case of odd, we will get only one value. For that purpose, B will be only one value. For even, B will have 2 values. One of them is right, one of them is wrong. And in case numbers ending with 5, so we will take the multiplication table of 5. So it will end either in 5 or with 0. So there are 5 values ending with 5, 5 values ending with 0. Here there are only 2 values, one of them is right, one of them is wrong. Easily we can find out. Whereas here 5, 15, 25, 1, 3, 5, 7, 9. They will end with 5, and 2, 4, etc. They will end with 0. So out of 5 values, 1 will be correct value. So how to cope up with such examples, that we will also see it later. So one more example of even number ending. So 3 digits. 8 ends with 2 and 16 means 2 cube we can subtract, not the 3 cube. So 2 cube 8, so subtract C cube. BC square ending with 0. Value of C is 2. 2 square is 4. 4 3 is 12. 12 means 2B ending with 0. So b is equal to dash dash 0 divided by dash dash 2. So it is 2 zeros are 0 or 2 5s are 10, which ends with 0. So either your value is of b is 0 or 5. So if it is 0, your answer is 202. If it is 5, your answer is 252. So 202 cube is this one, or 252 cube is this one. So comparing the Bijangs, if you observe, this will be correct value. And in the second method, if you divide by 8, to the 16, again it is even number, more than 6 digits. Here you can divide one more 8 times, 8 to the 16. So now it is odd number, 6 digit. We can find out easily. So this is equal to 8 into 8 into 25004 7. So cube root of 2. So when we want the cube root of 8 2, cube root of 8 2, 250, 7 ends with 3, 250 means 216. So 6. So 63 into 2 to the 4. 252, which we can see it. So as we have seen in case of even numbers, 2 was a minimum factor in the cube root, so that 2 cube 8 is a minimum factor in its cube. Similarly, when the cube ends with 5, if it is a perfect cube, 5 must be a minimum factor in the cube root, so that 5 cube 125 is the minimum factor present in this number. So we will have to divide by 125. So for dividing by 8 was much easier, but dividing by 125, how to divide? So this number, if we consider that 5 is a minimum factor, so that 5 cube, so we will have to divide by 125. While dealing with the multiplication, we have seen the numbers, any number into 5, 25, 125, 625, etc. So 125 is nothing but 1000 divided by 8. So when we multiply by 125, we divide by 8. Here we are dividing by 125, so the answer will be 37595 into 8 divided by 1000. So simply we will be multiplying by 8 and then taking 3 decimals backward. So which is very easy. Multiplying by 8 is very easy than dividing by 125. So we will divide first. 8 5 is 40. divided by 1000 means 1, 2, 3. So automatically this cancels. So this is 300463, whose cube root is 3 ending with 7. 300 means 6. So 67 is the cube root of this. And cube root of 125 is 5. So the value cube root of this number is nothing but 67 into 5, which is equal to 335. So in this way easily you can find out the cube root of numbers which are odd ending, even ending, or those which end with 5. So now let us begin with recurring decimals. As the name itself suggests, recurring means reoccurring. So when a numerator is divided by a denominator, that means when a number is in fraction form, we get the answer in decimal form. And many a times, depending on the nature of the denominator, this division is an endless job. Some set of numbers repeat again and again if we continue the division process. For example, if we divide 1 by 7, then the decimal form of this 1 by 7 is so the set of 1, 4, 2, 8, 5, 7 repeats again and again even if we carry on the division, and such set of numbers along with the decimal wherever possible is known as recurring decimals. So what is the speciality in nature of number or nature of denominator, so to say? Earlier we have seen for addition, subtraction, multiplication, division, etc. the nature of numbers was near base, near subbase and others. In this case it is odd, that is numbers ending especially with 1, 3, 7 and 9, even ending with 2, 4, 6, 8 and so on. So this is the nature. This nature will be useful especially in recurring decimals, divisibility and so many other topics. So depending on the type of decimals form, they form 3 different types of decimals. One is terminating, recurring and mixed. These are the 3 types of decimals we get. So let us see which denominators give terminating decimals, which give recurring and which give mixed. For example, for denominator 2, suppose if we get 1 upon 2. What is the value? It is 0.5. So it is a fully divisible and it is not occurring again and again. So 1 upon 2 is 0.5. It is known as terminating. If we take 1 upon 3, and we go on dividing 1 by 3, we get the answer 0.333. So 3 starts repeating again and again. So a dot is given or dash is given on the numbers which repeat again and again. In this case only 3 is being repeated, so it is 0.3 recurring. If we take 1 upon 4, it is fully divisible. If we take 1 upon 5, fully divisible. If we take 1 upon 6, so in this case it is a mixed, that is terminating as well as recurring. So the number 1 is non-recurring, whereas 666 is recurring. So it is a mixed. It contains both terminating as well as recurring. If we take 1 upon 7, a set of these 6 digits repeat again and again, so it is recurring. 1 upon 8 comes over here, 1 upon 9, 1 upon 10, 1 upon 11, 1 upon 12, 1 upon 13, 1 upon 14, 1 upon 15, 1 upon 16, 17, 18 and so on. So these will give recurring, mixed and terminating. So how to determine which numbers or which denominators will give terminating, recurring or mixed? Just if you observe 2, 4, 5, 8, 10, 16, etc. they contain the factors 2 and 5 only. So if we can consider 8, it is 2 into 2 into 2. If we consider 10, it is 2 into 5. So it will contain only the factors 2 and 5. So the numbers which have factors only 2 and 5, they will give terminating. Here 3, 7, 9, 1, etc. The numbers, odd numbers ending with especially 1, 3, 7, 9 only, but it will not contain 2 and 5 as factors. Whereas if it is mixed, then it will have both 2 and 5 as well as whatever the combination of both is. For example, if it is 6, it is 2 into 3, so it contains 2 also and 3 also. If it is 12, 2 into 2 into 3, so again it has both. 14, 2 into 7, like that, or 5 into 3, so 5 into 3, so it contains both this. So when it contains both 2 and 5 and any give 1379 ending, it will give mixed. So here you can see terminating, recurring, and so on for other numbers. Here you will get only recurring, here you will get only terminating. Vedic mathematics provides a single line method using two formulae. They are very simple. One is ekadikena purvena, or one more than the previous one, and another is one less than the previous one. So let us deal how to find the recurring decimals for 1 upon 90. For 1 upon 3, there is only one recurring decimal. One upon 7, there are 6 recurring decimals, and as we go on, there will be changes in the total number of digits which we get as recurring digits, and 1 upon 19 will have 18 recurring digits. So if we start actually by conventional method, we will be dividing by 19. So first we cannot divide, we give 0, 0 over here, again 0, so again one more, 19 5 are 95, then 5, again 1, 0, 2, and so on. So almost when there is a set of 18 recurring digits, we will be dividing 18 times. Whereas by simple ekadikena purvena formula, here for 1 upon 19, we can carry out in a single line. Just see how we can carry it out. 1 upon 19, it is almost equal to 1 upon 20, or ekadikena, 1 more of 19 is 20. So to get the equivalent fraction of 1 upon 20, if we divide by 10 to numerator and denominator, 1 upon 10 is 0.1, 20 upon 10 is 2. So instead of dividing by 19, we are dividing only by 2 to get the answer. So how it is done? So you start dividing in terms of quotient and remainder. So 1 divided by 2. We cannot divide 1 by 2. So it is 0. The remainder is 1. And whatever remainder is there, it will be fixed, prefixed to the earlier quotient. So 0 prefixed by remainder 1. So next dividend is 10 divided by 2. It will give 5. 5 divided by 2. It gives 2 to the 4, remainder 1. 12 by 2, later on 3. 2 ones are 2. 11 by 2. 15 by 2. 17 by 2. So I will continue from here. 18 by 2, and later on you go on dividing by 2 only. Now you got so many decimals. Continue. You will get the answer. And 1 means again we are starting we have arrived at starting point. So if you count this, the answer is 0.052631578947368421. So 18 recurring digits in a single line. Instead of dividing by 19, we have divided by 2 to get the answer. So in this example itself, there are 3 methods. One method, just now we have seen, dividing by 2 to get the answer. Another method, so when the number ends with 9, always, just we'll take first 2 examples. Unit place of the recurring digit and unit place of the denominator. If the denominator is 17, 27, 37, etc., etc., then unit place of this and unit place of this, the product is always 9. 3 3s are 9. 7 7s are 49, which ends with 9. So automatically, when we are dividing, now we know that the last digit, the product must be 7 7s are 49, 3 3s are 9. So here already the unit place is 9. So it is 9 1s are 9. So the last digit recurring is 1. When the numerator is 1. If it is other one, then accordingly the changes will take place. Now when we know that last digit is 1, we don't know what are the earlier digits. So how to cope up with this? So here we have, from left to right, we have divided and got the answer. Now we will go from right to left and multiply by 2. Instead of dividing by 2, we will multiply by 2. 1 into 2, 2 into 2, 4 into 2, 8. 8 into 2, 16, carry over 1. 6 to the 12 and 1, 13. 3 to the 6 and 1, 7. 7 to the 14. 4 to the 8 and 9, and so on. So this is the second method. Third method, during this division or multiplication, when we get the difference numerator minus denominator, whichever is greater, so 1 and 19 in this case, the difference is 18. During this division or multiplication process, whenever we get 18, mostly we get, otherwise continue. But whenever we get 18, just observe here, 17 divided by 2, 2 8s are 16, prefixed by 1. So our next dividend was 18. So this indicates, which is same as 19 minus 1. So this indicates 50% of the work done. Later on, you need not divide by 2 also. And it is say 18 by 2 is 9, which is the complementary from the first number. Complementary from 9. 5 and 4, 2 and 7, 6 3, 3 6, 1 8, 5 4, 7 2, 8 1. So 50% division by 2 and rest complementary from 9. In this way, we can write straight away 18 recurring digits for 1 upon 90. So usually the recurring digits are obtained when the number ends with 1, 3, 7 and 9. So in the similar fashion, say 1 upon 29, it has 29 minus 8, 28 recurring digits. Then 29th digit will be the first one. So we'll start, just see, directly we can go with this. So 1 upon 29 is almost equal to 1 upon 30, which is equal to 0.1 upon 3. Just we are dividing by 3 to get the answer. Now you see 29 minus 1, 28. We have arrived at 28. These are the 14 digits. Now you write in continuation complements from 9. And here 9, 6, 5, 5, 1. So these are the 28 recurring digits. Within no time we can write. So in this way you can write 129, 1 upon 39, or whatever the fraction it is, 14 upon 29, 13 upon 49, whatever it is. So whenever number ends with 9, you can bring number ending with 9 by converting the number into equivalent fraction so that the denominator ends with 9. So 1 upon 3, if we multiply numerator and denominator by 3, we will get 1 into 3, 3 into 3. So which is almost equal to 3 upon 10 or 0.3 upon 10. So we will continue. Point 3 upon 1, so it is 0.3 by 1, 0.3, 0.3, etc. So only one digit is repeated. So 1 upon 7, if you want to find it, the equivalent fraction is 1 into 7 is 7, 7 7s are 49, so which is almost equal to 7 upon 50 or 0.7 upon 5. So we go on dividing by 5. So 7 divided by 5, 5 ones are 5, 2. 21 divided by 5, 5 fours are 20 and 1. 14 divided by 5, 5 twos are 10 and 42. Now if you observe, the equivalent fraction was 7 upon 49. The difference between numerator and denominator, 49 minus 7 is 42, which is our next dividend. It means your 50% work is done. Later on continue giving complementary from 9. So 1, 8, 4, 5, 2, 7. So 7 our starting point. So it is repeated again and again. So likewise, when we use ekadikena purvena, we use this method. So let us begin with 1 upon 30. Now this number ends with 3. So to end with 9, equivalent fraction is into 3 divided by 3. So 1 into 3 is 3, 13 3 is 39. And 3 upon 39 is almost 3 upon 40 or 0.3 upon 4. So we will be dividing 3 by 4 to get the answer. 3 upon 4 we cannot divide. So 3 is the remainder. 30 divided by 4. 4 7s are 28. 27 by 4. 4 6 are 24. 3. Now if you observe 39 minus 3, numerator minus denominator is 36. So 50% work is done. The rest is complementary from 9. So these are the 6 recurring digits we get. For 2 upon 13, it is twice of this, or 2 into 1 upon 13. Otherwise, we can convert it as equivalent fraction so that it will be 6 upon 39 or 0.6 upon 4, and we continue. 6 upon 4, 4 1 the 4, 4 5 the 20, 4 3 the 12. Now if you observe, 39 minus 6 is 33. Here the 50% work is done. So 1 8 5 4 3 6. These are the recurring digits for 2 upon 13. So just we'll write these numbers over here. Now why I have written these fractions and their conversion as recurring decimals is all the fractions of 1 upon 7 or 1 upon 13, whatever the fractions we get for recurring digits, they are always in cyclic order. That means, say 1 upon 7, or 7 has got how many fractions? Later on 7 upon 7 is 1, so that is not a fraction. So 1 upon 7 to 6 upon 7, there are 1, 2, 3, 4, 5, 6 different values, like 1 upon 13 is this, 2 upon 13 is this, later on 3 upon 13, 4 upon 13 and so on. Now here the fractions are 1, 4, 2, 8, 5, 7. So if we write it, in a circular form, clockwise direction, then the value of 1 upon 7 so what is the value of 2 upon 7? We can calculate directly like this only. 2 upon 7 equivalent fraction is 2 into 7 is 14, 14 upon 7 7 the 49, and continue with the division. But just to show what is the cyclic nature of these fractions. Now it starts from 1, or the lowest of all these digits. After 1, which is the lowest? 2 is the lowest. So 2 upon 7 will start from So it starts from 2, 2, 8, 5, 7, 1, 4. 3 upon 7. So after 2, 3 is not there, 4. So it will start from 4. 4, 2, 8, 5, 7, 1. Likewise 4 upon 7. So after 4, next is 5. So 5, 7, 1, 4, 2, 8. 5 upon 7. So after 5, 7. And 6 upon 7. It starts from 8 as a maximum. So once we know 1 upon 7, we can write otherwise by division method directly we can write. Just to show what is the cyclic nature of this, because there are 6 fractions for 7 and 6 digits for 7, we were writing it like this. But what about 1 upon 13? Because 1 upon 13 they have got 12 fractions, 1 upon 13, 2 upon 13 and so on up to 12 upon 13. But the fractions or recurring decimals are only 6. So that's why I have taken second also. So this and this, there is connection is 07692915346, both are different. So there will be 2 cyclic measures or 2 cycles, 076923 and 153846. So 1 upon 13 it is here, 2 upon 13 it is here. Now what about 3 upon 13? So it has started with 0, later on 1. So next digit is 2. So where the 2 digit is, just observe, it is here. So it starts 3 upon 13, it starts from 2, 3. Now after 2 number is 3, but 3 is here also and here also. So which is to be considered? That we have to see. After 3 again it is 0 because it is repeating, and here. So it is 30 over here, 38 you consider next because both contain 3. So whichever is lower, that will be 4 upon 13. So 30 is here. So here 4 upon 13. Then again 3 is there, so 38. So it is here. And 6 upon 13. So next number is, after 3 it is 4. It is not present. So 4, 6. And so on. We can write all those things. Only thing, whenever the number is repeated in both, whichever is lower, that is for the lower. Whichever is higher, that is for the. So 30 is lower, it is for 4 upon 13. 38 is higher, it is for 5 upon 13. And so on, we can build up to 12 upon 13. So whenever number ends with 3, it is better, whenever the denominator ends with 3, it is better to multiply by 3 to get the number ending with 9. And whenever it ends with 7, there also you multiply by 3, but 7 3 is 21, it ends with 1. So the procedure is slightly different over here, because 9 plus 1 is 10, we are getting 0 at the end and we are cancelling that 0, and in case of 1 we are subtracting 1 to get the 0. So slightly procedure is different. How is that procedure? That we will see it. So here just we will take some 4-5 decimals, how it is proceeded, that's all. So here in case of 19 we were adding 1 to get 0. In this case 31 minus 1 is 30. So the formula used is Eka Nyundena Purvena, or 1 less than the previous one. So it is almost 1 upon 30 or 0.1 upon 3. In case of 1 upon 29, also it is 29 plus 1, it is 1 upon 30 or 0.1 upon 3. So in both cases we get 0.1 upon 3, but here Ekadikena Purvena, we are prefixing and adding the quotient and proceeding. So in this case what we were doing is 1 divided by 3, 10 divided by 3, 3 3s are 9, then 10 plus 3, 13 divided by 3, and so on. So here in this case to the prefixed number we were adding these quotient digits, because 29 plus 1 ekadikena formula was used. Here it is ekanyonena formula. We have to subtract this. Rest procedure is same. 1 divided by 3 we cannot do, so it is 0, 1. So value of 1 is prefixed. It is 10 minus 0 is 10 divided by 3. So this is 10 minus 3 is 7, 3 to the 6 and 1. Now 10 minus 2 is 8, 3 to the 6. 20 minus 2 is 18, 3 6 the 18 and 0. Now 0 minus 6 is bar 6. So we are getting a bar value. So bar 6 divided by 3 is bar 2. The remainder is 0. Now 0 minus bar 2. So minus of minus is plus. So 0 minus bar 2 is 2. 2 divided by 3 we cannot do. So now 20 divided by 3. 20 minus 6 is 14. And so on till whatever answer we want we can continue. Normally we require only 3 or 4 decimal points. Up to any point you can stop. So this is how ekanyonena purvena is used. So this number ends with 9, ends with 1. Earlier we have seen number ending with 3, 7, 9. So it is better when number ends with 3, you multiply by 3, so that number ends with 9 and you apply ekadikena purvena formula. For 9 you are applying ekadikena purvena. For 7 and 1 it is ekanyonena purvena, 1 less than the previous one. You multiply by 3 so that you will get a number ending with 173, that 21 ends with 1, and it is better to use. If you multiply by 7, then 7 3 that 21 you will get. At that time you can use x minus 1 or ekanyonena, or here if you multiply by 7, 7 7 the 49, there you can use. So you can either use one more or either use one less formula. So just we'll see how to club 2 2 or 3 points each. So 27 upon 199 is almost equal to 27 upon 200. So when we divide to get the equivalent fraction by 100, then 27 divided by 100 divided by 2. So this is the, instead of 199 dividing by 199, we will be dividing only by 2 to get the answer. Just now we will continue. Here when you cancel 2 zeros or when there are 2 9s, that means the grouping will be of 2 digits. If you cancel 3 zeros, grouping will be of 3 digits. For those 2 digits or 3 digits, you have to prefix if at all any remainder is there. So 27, 2 1s are 2, 2 3s are 6, or 13 2s are 26, remainder is 1, that is prefixed to entire group. So now your next dividend is 113 divided by 2. So 2 5s are 10, 2 6s are 12 and 1. Next 156 divided by 2. So no reminder. 78 divided by 2. 39 divided by 2. And so on. So you are getting 27 by 199 as 0.1356783918 and so on. How many digits you want, you can carry on this division. Swami Bharati Krishna Tirth, he has shown how Sanskrit language has been decoded to get the mathematical meaning of Atharva Veda shlokas, and accordingly he has given 3 sub-formulae which come under recurring decimals. And before that, what is the decoding formula that we will see. The decoding formula is Kadinama, Tadinama, Padipanchaka, Yadyashtakam, Shunyam. So this means the consonants which are present for our Sanskrit language, it is ka kha ga ga nga, cha cha ja ja ya, ta tha da da na, etc. So for these letters, say ka adi nava, means from ka there are 9 letters. So ka kha ga ga nga, etc. Nava means 9, like that ka kha ga ga nga, cha cha ja ja. Its value is 1. Ka means 1, kha means 2, ga means 3, gha, nga, cha, cha, ja, ja. Ya, it is not included, its value is 0. Tadinamo, starting from ta, next continuous 9 letters, means ta, tha, da, da, na, 1, 2, 3, 4, 5, ta, tha, da, da, na, ta, tha, da, da, 6, 7, 8, 9. No is not present, its value is 0. Padi Panchaka, Panchaka means 5. Pa, fa, ba, bha, ma, 1, 2, 3, 4, 5. And then Yadyashtakam, ya, ra, la, va, sha, sha, sa. 1, 2, 3, 4, 5, 6, 7, 8, ha. Ksha, Shunya. So value of Ksha is 0. So if we put, or if you use this decoded language, then we get the recurring decimals. The sub-sutras given here are the first sub-sutra or sub-formula is Kevalaihi Saptakam Gunya. That is the formula. Saptakam means 7 for 1 upon 7 or reciprocal of 7. Only Kevalaihi, that word is sufficient. Now as far as Kadinava, Tadinava, etc. are concerned, the value of Ka is 1. And in that matter, to this consonant, if vowels are added, Ka, Ka, Ki, Ki, Ku, Ku, Ke, Kai, etc., its value remains 1 only. So Kevalaihi means we want K means Ka, Va and La. What is the value of Ka, Va and La? Ka, Kha, Ga, Ga, Nga. Ka means 1. Va, Ya, Ra, La, Va means 4. And La, Ya, Ra, La means 3. So only 1, 4, 3. This number is sufficient to identify the recurring decimals for 1 upon 7, and that is nothing but 3 digits. You have to multiply by. We have seen it in the multiplication, 143 into 999, which gives, so now the recurring decimals, so I am giving the decimal point with 143 into 999 is, which is nothing but reciprocal of 1 upon 7. The second sub-formula is Kalau Shudra Sasai. That means for 1 upon 13, what are the recurring decimals? So Kalau means Ka means 1, La, your La means 3. So for 13, Shudra Sasai. Shudra means 0. Ksha. Sa Sai. Sa means Ya, Ra, La, Va, Sha, Sha, Sa means 7. Sa Sai means again 2 times Sa, Sa. So 077 is sufficient for finding out reciprocal of 13 or 1 upon 13. So it also means into. So this is equal to giving the decimal point 0, 7, 6, 9, 2, 3. So this is a 1 upon 13 in the form of decoded language, gives the value of 1 upon 13. One more formula, Kamse Ksham Dah Khalair Malai. That is the formula. Kamse, K and Sa, 1 and 7. So for reciprocal of 17, we have to remember Kshama, Daha, Khalai, Malai. So Ksha, Ma, Ya, Bafo, Baba, Ma, Daha, Da, Tha, Da, Dha, Na, Da, Tha, Da. 8. Ha, Yara, Lava, Shasha, Saha, Daha, Kha, Ka, Kha. 2. La, Yara, La, Ma, La. So this is sufficient. Sha, Ma, Da, Ha, Kha, La, Ma, La. That is sufficient. So as far as the formula is concerned, in the reign of council, what was the position at that time? How the people were there? That has been discussed in the formula. But this is decoded for 1 upon 17 or reciprocal of 17. So there are 1, 2, 3, 4, 5, 6, 7, 8 digits. So you multiply by 8 nines. And the answer is 16 recurring digits. And these are so this is the value of 1 upon 17. Just by using the sub formula, we can directly write it. So this is as far as recurring decimals is concerned, but just how this formula is used. Kadinava, Pradinava, Padipanchaka, Yadyakstakam, Ksha, Shunyam. There is one formula, or so to the one shloka is there. The first line of the shloka, it is Krishna Stuti, and second line of that shloka is Shiva Stuti. So each shloka, each line of the shloka, they contains 16 letters, and 2 lines means 32 letters. So that shloka will give value of pi to 32 digits. That shloka is Gopi Bhagya Madhuvrataha Shrungisho Dadi Sandhiga. Next line, Khala Jivita Khatava Galahala Rasandhara. So the first line contains 16 letters, second line contains 16, so 16 plus 16, 32, and the accordingly now Gopi Bhagya means Go, Pa, Bha, Ya. So Go means Ka, Kha, Ga. Pa, Pa, Pha, Ba, Bha, Ma. Bha, Pa, Pha, Ba, Bha. Ya. So actually it is pi value is 3 point. So we will get 32 digits, and these digits are 5926, 53589, 79323, 8462, 643383272. So the Gopi Bhagya Madhuvrata Shrungisho Dadi Sandhiga Khala Jivita Khatava Galahala Rasandhara. So this shloka gives 32 digits of value pi. And Swamiji has told that in this shloka itself how to write the further digits, that decoding is still required, and one has to research on this subject. So there are various norms to test whether a given number, that is the dividend, is divisible by another given number, which is divisor, without actual division. So for example, whether a particular number or given number is divisible by 2 or not. So instead of doing direct division, just observe the unit place. If it is odd, this number is not divisible by 2. If it is even, then it is divisible by 2. So what are the conventional norms to test whether the initial number, say from 2 to about 20, what is the divisibility test for that? So we are starting with divisibility. So when the divisor, or so to say number, is divisible, so whether 2 is divisible, any number is divisible by 2. So what is the norms? So it must be even ending. So if the number is, say, whatever number be there, if its unit place is even, that is 0, 2, 4, 6, 8, then it is divisible by 2. What about 3? In case of 3, the sum of all digits in a number, if they are divisible by 3, it is divisible by 3. That means now sum of all digits in terms of Vedic way, it is Bijank. So Bijank, if it is divisible by 3, then the whole number is divisible by 3. Whether this number is divisible by 3, means just find the Bijank. 3 plus 4, 7, and 6, 13. Now 13 is not divisible by 3, so the number is not divisible by 3. So if it is whether this number is divisible by 3, 6 plus 4, 10, and 5, 15. 15 is divisible by 3, so 1446 is also divisible by 3. What about 4? Last two digits of a number, if they are divisible by 4, then the whole number is divisible by 4, irrespective of whatever digits are there earlier. Whether this number is divisible by 4, just observe last two digits, 44, which is divisible by 4, and hence the whole number is divisible by 4. About 5, so if you consider a table of 5, multiplication table, 5, 5 to the 10, 15, 20, so if it is 0 or 5 ending, whatever be the number, if it ends with 5 or if it ends with 0, the whole number is divisible by 5. 6. So these are the conventional norms. Now 6, it has the factors 2 and 3. 2 into 3 is 6. So it should satisfy the condition for 2, that is even ending, and also of 3, that is Bijank, divisible by 3. If this is the case, if we take a simple example 12, even ending, so divisible 2 plus 1, Bijank is 3, it is divisible by 3, so the whole number is divisible by 6. 7. Conventionally, there is no test. 8. If last 3 digits are divisible by 8, then the whole number is divisible by 8. So whether this number is divisible by 8, you just divide these two mentally and see whether this number is divisible by 8. 8 1 is 8, then 0, 8 2 is 16, that means this is divisible by, so the whole number is divisible by 8. About 9, Bijank must be 9, that means 0, because we are cancelling 9 for finding out Bijank. So if it is either 9, that means 0, it is divisible by 9. So whether this number is divisible by 9, just cancel the 9s. So it is 0, so this number is divisible by 9. So 10, testing is 0 ending. If the number ends with 0, it is divisible by 10. 11. For 11, if the alternate digit, the difference between the sum of alternate digits, even place digits minus odd place digits, if it is divisible by 11 or 0, then it is divisible. For example, if this number is there, if it is divisible by 11, so what you do, you need alternate digits. So first, third, fifth, seventh and so on, add all together. 2 plus 3 5 plus 1 6, so it is 6 over. Then add even place digits 1 3 2 whatever it is, so 1 plus 3 plus 2 6. If the difference between odd and even additions is 0 or 11 or multiple, it is divisible. So 6 minus 6 is 0. That means this number is divisible by 11. Sum of even and odd digits. Their difference is 0 or 11 or multiple of 11, etc. Then it is divisible. For 12, it is 4 into 3. So the condition for 4 as well as 3, it must be satisfied. 13, there is no test. 14, as 14 is 2 into 7, but there is no test for 7, so no test for 14. 15, 3 5 are 15. We have test for 3 and 5. If both are satisfied, test for 15 is satisfied, and so on. So later on, you can see that test was not there for 7, for 13, 14, later on. (19), 21, 31, a number ending with 1, 3, 7, 9, which form are prime numbers, or prime number as a factor. See, in case of 21, it is not a prime number, but factors are such that they are primes. There is no conventional test, whereas Vedic mathematics provides Vedic mathematics provides a test whether a particular number is divisible by those prime numbers or not. In the earlier also we have seen, in case of recurring decimals, when the number ends with 1379, how to carry out the reciprocal value. In the similar fashion, 1379 is very important from the point of view of divisibility. When the number ends with 1, 3, 7, 9. And the process is known as oscillation, and Sanskrit formula for that is Veshtanam. It is sub formula Veshtanam. Veshtanam means actually covering. A big number, when we remove the covering, it becomes very small. It is like a mango. When we peel it and ultimately we get a seed. So it is the seed that we are using instead of the actual number, and that number, after removing the shift, so to say, is known as oscillator. So instead of numbers which end with this, we are using what is known as oscillator, which is very small number compared to actual numbers. So for example, number ending with 9. So in this case, ekadikena purvena formula is used. So when we add 1 to this, it becomes 20, 30, 40. Just cancel this. So we get 2, 3, 4, etc. So it is known as, because we have added 1, it is known as positive oscillator. So oscillator for 19, positive oscillator is 2, for 29 3, 39 4, for 69 it is 7, and so on. So instead of to verify whether this any number is divisible by this, if it is to be seen whether the number is divisible by 69, we will be operating with 7 and not with 69. What is the procedure? As it is a positive oscillator, we are, because we are adding 1, it is known as positive oscillator, denoted by P. P means positive oscillator. Say for example, whether this number is divisible by 19. So what is the procedure? The procedure for using oscillator or positive oscillator is known as oscillation. So what is the oscillation process? Oscillation process is unit place into positive oscillator, that is P, add to the remaining number. So in this case, just we'll see whether it is divisible by 19. Then for 19, P is how much? 19 plus 120, cancelling 0 is 2. So we will be operating with P as 2. Unit place is 8 into P is into 2. 8 to the 16. So add to the remaining number, 193 plus 16. Now this also is a big number. I don't know whether it is divisible by 19 or not. So what you do, again continue the same process. This is unit place of this number, 9 to the 18, add to the remaining 20. So 20 plus 18, 38. Now we know 19 to the 38. But even then we can confirm. I don't know whether 38 is divisible by 19. Unit place into P, 8 to the 16, remaining 3 is 90. That means this number is divisible by 90. Another procedure is there. We'll take the same example. The oscillation process here is unit place into P plus, so this is one procedure, this is another procedure. That means add to next digit or earlier digit, or higher place digit. Unit means add to tens, add tens, add to the hundreds, hundreds to thousand, and so on. So just see, now P is 2, 8 to the 16, instead of adding to 193, just add to this 3. 8 to the 16 plus 3 is 19, write the product or addition and product just below the tens place. Now again, unit place into P, 9 to the 18 plus 1 is 19, add to the previous digit, means unit tens, hundreds. So 19 plus 9, 28. Again continue till 8. 8 to the 16, 17, 18, and add to this is 19. So this number is divisible by 19, so the whole number is divisible by 19. So either you can add digit by digit or to the whole number. So the process is unit place into oscillator, add to the remaining number, or unit place into oscillator, add to the earlier digit, and continue till you get highest place or last digit. Once it is known that it is divisible, and when the number ends with 9, then automatically you need not have to divide to see what is the quotient, but directly you can write what is the quotient, and it is the simple formula, last from 10, others from 9, that is Nikhilam Navatash Charamam Dashataha. So 9, 9, 19, or last from 10, 8 and 2 is 10. So consider the digits which have oscillated right from first digit of the number. So last from 10, others from 9. So 102 is the quotient. Here also 102 is the quotient. So 1938 divided by 19 will give 102. So whether this number is divisible by 19, so just for the practice it will be okay. So 7, so here for 19, P is equal to 19 plus 120, cancelling 0 means P is equal to 2. Go on adding either to the number or second method, we will try both methods. 7 to the 14, add 14. 7 to the 14, 9 to the 18, 8 to the 16, 8 to the 16. Yes, so last number is 19. It is divisible. Just you can say. This is the quotient. Or if we proceed the other method, seven to the 14 plus 3, 17, 7 to the 14, 15, 19, 18, 19, 28, 16, 18, 16, 17, 19. So it is 0, 819, 819, 9072, last from 10, 11023. Whether this number is divisible by 29. Now P for 29, 29 plus 130 cancel 0, so P is equal to 3. So instead of dividing by 29 and seeing whether it is divisible by 29, we are osculating the number with 3. So now once we know the technique, it is better in a single line to get the reading. So digit by digit addition is better than adding the whole remaining number. So we'll stick to this number now. Stick to this procedure. 3 5 the 50 and 0. 15, 16, 6, 10, 8, 25, 29. Just will write 1.17. So 5 oscillated, 5 3 is 15 plus 0, 5 3 is 15 and 7, 2 3 is 6 and 4, 0 and 8, 8 3 is 24 and 1, 5 3 is 15 and 4, 9 3 is 27 and 9. So apply the formula. Last from 10, others from 9. So this number divided by 29 is equal to 419745. This is the question. Now whatever two methods which we have seen, we were starting from unit place to higher place, whereas in the similar fashion the reverse oscillation process, one more method is there which is called as reverse. Means instead of from unit place to higher place, we are going from higher place to unit place. So it is just the same as division process. Because in case of division also, we start with number divided by 29. Means 29 ones are 29. Whatever it is, we are starting from higher place to unit place. It is the same thing, but instead of dividing by a whole number, we will be dividing with some changes and see how it works. So whether this number is divisible by 29. So for 29, positive oscillator P is equal to 3. So first the normal methods which we have studied. Unit place into oscillator 21 and 3. 4 3 is 12 plus 5. 7 3 is 21 and 8. So it is divisible. And applying the formula, quotient is 253. So the second method, 7337, whether it is divisible by 29 or P is 3. So 7 3 is 21, add it here, 733 plus 21 gives 754. Now again 4 3 is 12, 75 and 12, 87. Again 7 3 is 21 and 8, 29. So this is the divisor, that means it is divisible. Last from 10, others from 9, we get same as quotient. Now we can shift to a new method which is reverse oscillation. Here we have started from unit place onwards. Now we are going reverse way, that's why it is known as reverse oscillation process. So instead of 29, we are dividing by 3. So what is the procedure for this? Last digit, whatever number we get, is the remainder, and especially this process is useful whether the number is divisible or not. We get quotient as well as remainder. Now we are dividing by 3, so 3 is our divisor. 3 2s are 6. As in case of division, what we are writing, just write the same thing, but prefix the remainder to the next digit. So 3 2s are 6, so 7 minus 6 is 1, prefix to the next digit. So its value is now 13. Because we have added 1 to get the oscillator, the procedure is whatever number is there, add the quotient. So 13 plus 2. So add the first quotient now, it is 15. Write the sum. Now divide by 3. 3 5s are 15. Remainder 0. So 3. Now the second quotient is 5. 3 plus 5. Now divide by 3. 3 to the 6. Remainder is 2. That is 27. Whatever value we get here is the remainder. And remainder is 27 plus the third quotient. 27 plus 2 is 29. Now 252 is the quotient, 29 is the remainder, but 29, our divisor is also 29, so it is 29 divided by 29, means it is 1 quotient. So actual quotient is of 29, so totally it will be, which is same as earlier. 7802 34, whether this is divisible by 79. Just we'll take one earlier example, 780234. So here P is equal to 8. We'll start with digit by digit. 8 4s are 32, 35, 5 8s are 40, 45, 44, 44, 43. Last number is 43, which is not divisible by 79. So the whole number is not divisible. So let us see here. So what is the remainder? It is at the below last digit. Now 8 is our oscillator. We start 8 9s are 72. 6 is the remainder prefix to the next digit. 60 plus 9, it is 69. Divide by 8. 8 8s are 64 and 5, 52 and 8. Second quotient. Divided by 8. 8 7s are 56. 43 plus third quotient 7. Divided by 8. 8 6s are 48 and 24 and 6. So when you divide 780234 by 79, you will get 9876 as quotient and 30 as remainder. That means when you are getting some remainder, it is not divisible. Here, if the number is not divisible, you don't get whatever the quotient is or remainder is, but by reverse oscillation, you can find what is the quotient and remainder. So whether number is divisible by 59. So here P is equal to 59 plus 1, 60, cancel that, 0, so with 6, we start with this reverse oscillation, 6 1 the 6, remainder 0, 1 plus 1 is 2, you cannot divide, 22 plus 0, 22, 18, 47 and 50, 23 and 8. We'll check it again. 6 1 the 6, 0, 10, 1 and 1, 2, you cannot divide, 22 and this 22, 6 to the 18 and 4, 22, 47 and 50, 6 8 the 48 and 2, 23 and 8, 31, so not divisible. Whether this number is divisible by this. So it is ekadikena purvena. Means when one is added, it becomes 20,000 and we can cancel 4 zeros. Hence the positive oscillator P is when you cancel how many number of zeros according to you write P1, P2, P1 you need not write because it is P. When you cancel 2 zeros, P2. When you cancel 3 zeros, P3. Now you are cancelling 4 zeros, P4. This indicates you have cancelled 4 zeros and a grouping of 4 digits is required from right. And value of oscillatory 2. So instead of dividing by 19,999, you are dividing by 2 to get the answer. So it is a group of 4 digits from right. We are dividing by 2. Now 1 divided by 2. It is a group. So if now the third group is only 1. 1 divided by 2 we cannot divide. So 1 is the remainder which is carried forward. So this plus 0 is 19,703. Here you divide by 2. 2 5 are 10. 2 1s are 2, carry over 1. So this remainder is carried forward. So now to this add 9,851. So this is the last group. 19999, which is same as this. That means it is divisible. So this is the quotient, this is the remainder which is equal to 1 quotient. So actual quotient is 9851 plus 1 is 9852. So this is how the positive oscillator can be used to carry out the oscillation by oscillation process to see whether the number is divisible by given device. So now let us deal with the numbers which end with 1. So for example 11, 21, 31, 41, etc. They are the numbers which end with 1. And in this case, when we subtract 1, we get number ending with 0 and cancelling this we get 1, 2, 3, 4, etc. So instead of 41 we will be dividing by 4 or processing or oscillating by 4 for 31, 3, 21, 2 and so on. So this is because we are subtracting 1, it is known as negative oscillator. A positive oscillator is denoted as P, negative oscillator denoted as Q. So in this case for 11 Q is equal to 1, for 21 Q is equal to 2, for 31 Q is equal to 3, for 81 Q is equal to 8, for 201 again Q2, because we can cancel 201 minus 1 gives 200 and we can cancel 2 zeros and hence Q2 is equal to 2. If it is 30001 minus 1 gives 30,000, we can cancel 4 zeros, so it is Q4 is equal to 3. Like this the negative oscillator is calculated. Now let us see whether this number is divisible by 31. So in case of 31 minus 1 is 30, cancelling 0. So because it is minus, it is called a negative oscillator Q. Q is equal to 3. So when Q is written, you should understand it is negative oscillator. When P is written, you should understand it is positive oscillator. And the procedure here is slight different whatever we have seen for positive oscillator. In case of positive oscillator, we were multiplying by unit place by positive oscillator and adding to the number. Because it is negative oscillator, we have to subtract the number. That is first difference for method 1. Where we were adding to the whole number. So here Q is 3, but because it is Q means negative, we have to subtract the product. That is the only difference. So 5 3s are 15, subtract 15. Again unit place into 3, subtract unit place into 3, subtract unit place into 3, subtract. So 3 3s are 9, 9 minus 9 is 0. So when you get 0 or the divisor itself, that is 31 in this case, or their multiple, it is divisible. If you get some number which is not divisible by 31, then it is not. So this is how you can say that 99665 is divisible by 31. Second procedure. Adding to the earlier digit, but here as it is a negative oscillator, first and foremost part when you are doing it digit by digit method is consider from unit second, fourth, sixth, depending on the total number of digits, consider this as negative or just give a bar. So this is positive, negative, positive, negative, positive, negative, positive, negative. It continues. So 6 you have to consider it as bar 6. 9 you have to consider it as bar 9. Whether the sum is double digit, you have to change the sign of tens place digit. That is the only change. Now let us start. 5 3s are 15. Now it is bar 6. So 15 minus 6. 9 3s are 27 plus 6, 33. Now it is a double digit. Tens place is considered as negative. 3 3s are 9. 9 minus 3 is 6. 6 minus 9 is bar 3. Bar 3 into 3 is bar 9. Bar 9 and plus 9 is 0. So at the end we got 0. It means the number is divisible by 30. Now how to find the quotient in such cases? You write, because in case of positive oscillator you were using Nikhilam Navatas Charamam Dasha, the last from 10 formula, whereas here you cannot use that formula because it is minus 1, and so you just first write whatever digits you have oscillated at each stage, and finally you got 0. Here also in the similar fashion. So whatever number is there, 0, 3, 2, 1, 5, that itself is the oscillator, quotient. So 99665 divided by 31 will give you 3215. But if you observe here, it is altogether different. How to understand? So what you have done in the negative oscillator is your second digit, fourth digit, sixth digit was negative. That means positive was negative, positive was negative. So if it is negative, it will be positive. So do the same thing over here also. So this remains positive. Second 9, it is positive, it becomes negative. Third is positive, or whatever number is there, it remains as such. Here. Fourth becomes reverse, means already it is negative, it becomes positive. So sign of second, fourth, sixth, eighth is changed. If it is positive, it becomes negative. If it is negative, it becomes positive. Now you convert this Vinculum number into normal. This is 3. 3 bar 9 means 30 minus 9 and 5. 3215. 3215. Now if you come to the third method, reverse oscillation, so that last here it will give remainder, here it will give quotient. So we are dividing, because Q is equal to 3, we are dividing by 3. 3 3s are 9, 0. Now earlier in case of positive oscillator, we were adding the prefixed number and quotient because it was positive oscillator. Now this is a negative oscillator. You have to subtract the quotient. Instead of adding the quotient, we have to subtract the quotient. That is the only difference. So 9 minus 3 is 6. You write it downwards. Then divide. 6 by 3. 3 to the 6. Remainder 0. Again, this minus second quotient is 4. Divide by 3. 3 ones are 3. 1 is left. 16 minus 1, 15. Write it at the bottom. Divide by 3. 3 5s are 15. Remainder is 0. And now 5 minus 5 is 0. So remainder is 0. Quotient is 3215. Whether it is this procedure, this or this. Only thing, if this is not divisible, you don't get the value in these two cases. If not divisible, here you will get quotient as well as remainder. Whether the number is divisible by 201. So 201 minus 1 gives 200. So we will be cancelling 2 zeros. So it is Q2. Because we have subtracted, it is negative oscillator. Cancelling 2 zeros means Q2 and value is 2. That means Q2 means we have to group to 2 digits from right for reverse oscillation and proceed. Q2 is 2, means start dividing by 2. 2 6 are 12, 112 because it is negative oscillator. 112 minus 6, 106 by 2, remainder is 0. 60 minus 53 is 7. So 653 is the quotient, 7 is remainder. How to find the divisibility when the number ends with 1 and 9? Now remaining only is 13, 3 and 7, number ending with 3, number ending with 7. So for example, if we take 3 or 13, if you multiply by 3, it will give 39 number ending with 9, whether it is. So whenever number ends with 3, multiply by 3 so that the number ends with 9. When number ends with 9, you get positive oscillator. In this case it is 4, in this case it is 7. So for 23, positive oscillator is 7, for 13, positive oscillator is 4. Suppose to the same number, if you multiply by 7, 13 into 7 is 91. So 91 minus 1 is 90. So because it is minus, it is Q. Q is equal to 91 minus 190, cancelling 0, it is 9. So for 13, positive oscillator is 4, negative oscillator is 9. Similarly for 7, just I am showing the example whether number ends with 3 or with 7. So 7 into 7 gives 49. Plus 1 gives 50, that means positive oscillator is 5. If we multiply by 3, 7 3s are 21. Negative oscillator for 7 is 2. Now if you observe, P plus Q is how much? In this case, P plus Q is 5 plus 2. 7, which is the divisor itself. For 13, what is p plus q? 4 plus 9, 13. So always positive oscillator plus negative oscillator is divisor itself. So once we know either P or Q, we can find the other. So for example, for 19, P is 2, divisor is 19. That means Q is 70. And to operate with 2 is easier than 70. So better to operate with 2. Whether this number is divisible by 27. So 27 into 3, 81 means 8 is Q. If Q is 8, its P is 27 minus 8 is equal to 19. So which is easier to operate? 8 is easier to operate. So Q is negative. So you start dividing by 8, and whatever number or quotient you get, you have to subtract because it is Q. 8 to the 16, 22 minus 2, 8 to the 16, 42 minus 2, 8 5 the 40, 5 minus 5, so remainder is 0, quotient. Now this is not the quotient for 27 because you are multiplying by 3 to get 81 means 8 as negative. So this is Q for 81 because you are dividing by 8. We want quotient for 27. So proportionately 27 3s are, so you multiply quotient by 3. So it is the actual quotient when it is divided by 27. So 18225 divided by 27 is equal to 675. The divisibility of numbers which end with 1, 3, 7, 9, that is the odd ending numbers. The numbers which end with 2, 4, 6 and 8, which are even ending. Now in this case, we will be operating only with what is known as reverse oscillation. Now if you observe 2, 4, 6, 8, the minimum even digit, that is 2, is present in all these digits, or whatever number is there, there also, because the number is even, it contains 2 as minimum factor, and hence instead of using the formula used for this reverse oscillation, they are sopantyadvayamantam or ultimate and twice the penultimate. So how this formula, or in Sanskrit sopantyat, so this formula is it, how this formula is used and how to find the positive and negative oscillators. When the numbers end with 2, 4, 6 and 8, that we'll see. In case of 1, 3, 7, 9, we were either adding 1 to get 0 or subtracting 1 to get 0. When we were adding 1, it was a positive oscillator P, and when we were subtracting 1 to get 0, it was the negative oscillator Q. Now, in this case, we are adding plus or minus 2. So, if we consider say 8, 18, 28 and so on, if we add 2, so 8 plus 2, 10, 20, 30, cancelling this. Because we added 2, it is known as positive oscillator, but if you do denote P, it may be confused with the earlier plus or minus 1. So let us give P dot for this. So P dot is the positive oscillator for even divisors. Similarly, if we take if we subtract 2, we get 10, 20, 30 and cancelling the 0, we get values 1, 2, 3, and because we have subtracted 2, it is negative oscillator Q, but to get correct relation, instead of P and Q for plus and minus 1, let us denote P dot and Q dot for even numbers or even divisors. So suppose if we take number 2, so when it is minus 2, we get 0 at the end, so that it is negative oscillator Q dot. And when we add 2 to number ending with 8, it becomes 0, and because we add 2, it is positive oscillator P, denoted by P dot. Now how to find the oscillators for numbers ending with 4 and 6. Let us take one example. 14. What is the oscillator or positive oscillator or negative oscillator for divisor 14? Suppose if we multiply by 2, you get number ending with 8, and 28 plus 2 will get 30. So positive oscillator is 3. Suppose if we multiply by 3, 14 3s are 42. If it is minus 2, 42 minus 2 is 40, cancelling 0, we get 4. But because we have subtracted 2, so it is Q dot. So P dot for 14 is 3 and Q dot for 14 is 4. So what is the relation? Earlier we have seen, in case of plus or minus 1 or odd ending divisors, P plus Q was divisor itself. Now let us see in this case, divisor is 14. So here P dot is 3, Q dot is 4, and our divisor is 14, but the answer is 4 plus 3 is 7, so which is half of 14. That means P dot plus Q dot is equal to half the divisor. That will be the relation. So once you know P dot, you can find Q dot, or once you know Q dot, you can find P dot. Let us take 26. So if it is multiplied by 2, you get 52. So minus 2, it will get give Q dot, because we are subtracting 2 from this, and 52 minus 2 is 50, so Q dot is 5. If you multiply by 3, it is 78, plus 2 will give number ending with 0, plus 2 is 80, cancelling 0, because you have added, it is P dot 8, and P dot plus Q dot, 8 plus 5, 13, which is half of 26. So the relation P dot plus Q dot is equal to half the divisor holds good for any even number. So either by multiplying by 2 or by 3, you can find positive or negative oscillator, P dot or Q dot, the one which fits or one which is lesser, that can be easily used for finding out the divisor. The procedure for reverse oscillation remains almost similar, with only the use of ultimate and twice the penultimate. That's the formula only. That is the only change which is there. So how to check the divisibility? Let us see. So reverse oscillation process, it gives the divisibility. If a remainder is there, you will get the value of Q as well as R. If R is 0, means the number is divisible. For example, first 96520, whether this number is divisible by 38. So in case of 38, as 38 plus 2 is 40, it is P dot, cancelling 0, 44. So we will be operating or dividing this number by 4 or oscillating by 4. So 4 to the 8, remainder prefix to the next digit. So in case of plus and minus 1, what we were doing? We were adding to this number the quotient part. This whatever prefix number and second quotient. Prefix stands third quotient. But here, because it is plus and minus 2, we will be using Sopantya Dvayam Antyam. That means ultimate and twice the penultimate. So in this case, 16 is ultimate, penultimate is 2. So every time twice the quotient we will have to add for positive oscillator P dot, or subtract twice the quotient for negative oscillator Q dot. So here, because it is positive oscillator, we will have to add double of this quotient. So 16 plus twice of 2 is 4, it is 20. Divided by 4, 5. Remainder 0. 5 plus double of 5, which is 10, and 10 and 5 is 15. Again divide by 4. 32. Now 32 plus twice of 3 is 6, which is 38. 36 and 2, and whatever we get at this point, it is the remainder, and this is the quotient. So 28 plus twice of 9. Twice of 9 is 18. 18 plus 20 is 38, which is the divisor itself. So R is equal to 1 quotient, because 38 divided by 38 is 1. So actual quotient is plus 1. So no remainder. So this is the answer. So when 96520 divided by 38 is equal to 2540. So this number is divisible by 38. Whether 102848 is divisible by 32. Now in this case, 32 is the number. When we subtract 2 from this, we get 30, because we have subtracted, it is q dot, and 32 minus 2 is 30, cancelling 0, 3. So q dot is equal to 3. So let us start dividing by 3. 3 3s are 9, 1 is left. Now because it is q, means negative oscillator, you have to subtract twice of quotient. So 12 minus twice of 3 is 6. 12 minus 6 is 6. Divide by 3. 3 2s are 6. Remainder is 0. 8 minus twice of 2 is 4. Remainder is 4. 8 minus 4 is 4. Divide by 3. 1s are 3. 14. Twice of 1 is 2. 14 minus 2. 12. Divided by 3. 4. 3 4s are 12. Remainder is 0. And the answer here in last column is 8 minus twice of 4, which is 8. So 8 minus 8 is 0. So which is remainder, this is quotient. So as the remainder is 0, this number is fully divisible by 32, and its quotient is 3214. Whether 10752 is divisible by 24. So the first one ended with 8, earlier one ended with 2, now it is ending with 4. So now 24 into 2 gives 48. If we add here, so 48 plus 2 means P dot, 48 plus 2 is 50, means 5. So we will be operating with 5. Five 2s are 10, remainder is 0. Because it is positive oscillator, twice the quotient is added. So 7 plus twice of 2 is 4, 7 plus 4 is 11. 11 divided by 5, 5 2s are 10, 1 is left. 15 plus 2 2s are 4, 15 plus 4 is 19. Divided by 5, 5 4s are 5 3s are 15. 42, and 42 plus twice of this is 48. So this is the remainder and quotient for 48, not for 24. So just I will write. So what we have done here is to be done using proportionality formula, that you have multiplied by 2. So for quotient you multiply by 2. So that it is 4, 4, 6, which is quotient for 24, and 48 is remainder for 24. But it is twice of divisor, so this is nothing but twice of quotient. So it is 446 plus 2 gives 8. So this is the actual quotient, and remainder becomes 0. That means this divided by 24 is 448. Now here in this case 26 into 2 gives 52. 2 more than getting a 0. So reduce 2 to get the 0. So because we have reduced, it is q dot is 5. So when it is q dot, we have to subtract twice the quotient. 5 3s are 15. 42 plus twice of 3 is 6, which is to be subtracted because q dot is our oscillator, negative oscillator. 42 minus 6.
So let us start
36
with the topic.
5 7 are 35. 19 twice of 7 is 14. So 19 minus 14 is 5. Divided by 5 is 1. Remainder is 0. So actual value E here is 8 minus twice of 1 is 2, which is to be subtracted. So 8 minus 2 is 6. So 6 is the remainder, and 371 is the quotient for 52. So we have multiplied by 2, multiplied quotient by 2. So 745 is the quotient for 26 plus remainder 6 for 26. So it is not fully divisible, and we are getting some remainder. So this number is not divisible by 26 because we are getting some quotient. So whether this number is divisible by 498, if we add 2 to 498, we get 500. So we will be, because we have added 2, it is positive oscillator P dot, and 500 will be cancelling 2 zeros, and P dot 2 is equal to 5. So it will be 2 means grouping of 2 digits from right. 5. So 3 divided by 5, 0 is 0, 330. Twice of this is 0, so it is 330. Divided by 5, 66, again it is 0. We have, because it is positive, we have to add 66 into 2, twice the quotient. So 132 and 96. 228 divided by 5. 5 4s are 20, 5 5s are 25, 3. 314 plus twice of 45, which is 90, 404. So this is the quotient for 498 and it is the remainder for 498. So when we divide this number by 498, we get 6645 as quotient and 404 as remainder. So whether this number is divisible by 5002. When we subtract 2, we get 5000 and we have to cancel 3 zeros, so that because we have subtracted, it is q dot 5000 means 3 zeros we are cancelling, that means q dot 3 is equal to 5. So now q dot 3 means every time we have to take 3 digits from right. And divide by 5. 2 divided by 5, 0. Twice of this, so it is, because it is q, we have to subtract the quotient. Now it is 0 over here, that makes no difference. This divided by 5. $17.86, and now this is 17.86 minus twice of 582, so which is it is to be subtracted. So 1786 minus twice of 582, which is 1164, 622. So this is the remainder for, and this is the quotient for. That means this number is not divisible by 5002 and its quotient is 582 and remainder 622.